Okay, a few more of these questions. So, question 10 of exercise 2D. A bushwalker can walk at 5 kilometers an hour through clear land and 3 kilometers an hour through bushland. So, if she has to get from point A to point B following a route indicated at right, find the value of x. So, find this distance so that the route is covered in minimum time. So, if you can't picture what's happening, she's standing over here, wants to get over here. She needs to go through the bush at some stage and through the clearing. We're not sure what she'll do. She could just go directly through the bush and then all the way through the clearing. That's one option. Okay, she could go through here and up. Okay, she could take the line that's marked on the diagram, or she could just go directly to the point B. Okay, we're not sure which one's the best one, which is why in this diagram we've said let whatever this distance is be x. Okay, we can't really define it very well. Let's try and do that anyway. Let the vertical distance up the bush be x. Okay, so this whole distance is 3 kilometers, so I know that the remainder here will be 3 minus x. Alright, so here's where it's going to get interesting. Bushwalker can walk 5 kilometers an hour, so for this section she's walking at a distance at a speed of 5 kilometers per hour. For this distance she'll be walking at a speed of 3 kilometers per hour. Okay, this distance here will be square root of x squared plus 2 squared, okay, or the square root of x squared plus 4. Okay, just using Pythagoras theorem. You can do that formally if you need to. Okay, a squared plus b squared equals c squared. Okay, pretty horrible CJ. You should do better than this. Okay, so the total time. Let's let total time be t as well. And that's the thing that we're trying to minimize. This total time will be the time in the bush plus the time in the clear. Alright, so how long does she spend in the bush? Well, I've got this formula, time equals distance divided by speed. The distance she travels is root x squared plus 4, and the time taken, and the speed is 3 kilometers an hour. Okay, so that total distance in the bush will take her square root of x squared plus 4 divided by 3. Okay, then I can look at the time in the clearing. The distance that she travels in the clearing is 3 minus x, and she travels that for 5 kilometers. She travels that at a speed of 5 kilometers per hour. Okay, from here you'll be able to differentiate t, so you'll be able to find dt dx. Okay, set it equal to 0 and find any turning points. Should be okay from there. Probably write this as a third x squared plus 4 to the power of a half plus a fifth of 3 minus x. Okay, before I differentiate it. Okay, we've got another problem, another speed and time sort of problem. Cost of running a train at a constant speed of v kilometers an hour is this price per hour. Okay, I need to really look at these dimensions carefully. This is the dollars it costs per hour. Okay, so the cost of running this train is 50 plus b squared on 1,000. Okay, so it'll look something like this. The faster you go, the more it's going to cost you per hour to run the train. Okay, so we can imagine that $50 is just for the driver's salary per hour, and the V is the velocity. So the faster we go, the more fuel we'll burn. It'll get more expensive per hour. Alright, so let's have a look at part A. Find the time taken for an 800 kilometer journey in terms of V. I know that speed equals distance over time. Okay, so my speed is V. My distance is 800 and my time is unknown. I can rearrange this to get time by itself. I'll rearrange it properly, so I'll multiply both sides by t. Vt equals 800, and then divide both sides by v. Okay, that's part A done. Part B, hence find an expression for the cost of this big journey. Okay, the total cost, again, I'll let total cost be capital T. The total cost is the cost per hour times the number of hours, or the time. Okay, so if my cost per hour, it costs $2 per hour, and it takes 5 hours, then the whole trip will cost $10. So let's substitute those values in. My cost per hour is this function, 50 plus b squared on 1,000. And I need to multiply this by the number of hours, which is the time taken for that 800 kilometer journey. Okay, so times 800 over v. Okay, from here I'm done. I could differentiate, but I'll just do the expansion first. So 50 times 800 on v, put the 3 zeros there and then a 40 in front of it on v, plus, it's going to be interesting, 800 v squared on 1,000 v. Okay, clean this up a little bit more. So cancel some numbers here. 8 on 10, same as 4/5, and v squared divided by v is just v. Okay, so this is the function that I'll then differentiate, find where the stationary point is, and